Alright everyone, in this video, this is going to be the continuation of the previous video, which is the start of the construction of the Zen Toolworks CNC mill. This is going to be, again, a continuation where I finish things up. There's probably going to be another video after this, but it's going to be short, it's going to be succinct. It's just going to be the final touches, that is putting screws in a few places. This is going to be where you actually see most of the CNC mill come together, which is putting together of the structural components, finalizing everything, etc. That being said, let's get started. I'm going to try and do this in a single video format rather than that really shoddy editing that I applied in the first one. So, let's go. Alright, well, I kind of just fucked up on the, not needing multiple shots. So I'm going to have to edit this together, because I kind of attached the wrong fittings in the first try. Obviously, this is the setup we started out with. Gantry parts, so x-axis, y-axis, and then we haven't started on the z-axis yet, but we're going to. So now is the process when we attach the actual moving slide components to the lead screws. As you notice, you have 3 lead screws, each in decreasing size. That one's the one for the z-axis, it's the shortest. This is the one for the y-axis, it's the next shortest. And this is the longest, so this is the x-axis. Now, the key to attaching the anti-backlash nuts to the lead screw is to hold the nut against the body and then screw the socket cap nut into it, the socket cap screw. Because if you'll notice, there's only enough clearance to fit a flat face up against there. There's not enough clearance to get the socket cap screw on. So you'll know if you do it the wrong way, which way is the wrong way, pretty quickly. Obviously, with one screw in, don't tighten it all the way. You'll need to do some little adjusting. So now that you've got it roughly in place, then do exactly as before. Hold the nut against the face. Take the screw, put the screw through, and then just thread it 1 or 2 times just to get it tight. Before now going all the way. It's important to know that you want to get it tight, but you don't want to tighten it to the point where you can't get it out, or tighten it to the feeling where you start to feel something give. That's because once you feel that sensation, that's when you're going to start pressing the washer into the PVC workpiece. I know because I just did that. So don't do that. Don't be me. Alright, now 1/2 of our moving slide is complete. Put the other side on, and then get the larger set of linear rails, which should be these. And now is the actual fun stuff. First, what you're going to do is you're going to stick, and that's on the wrong way. You're going to stick the linear slide through. Then you're going to do it with the other one. As I just noted, you want to keep both screw sides facing upwards. And now we get to the really fun stuff, which is the actual attachment to the motor block. Feed that through, align those, and then just take these largest socket caps, and just gently thread them on with your fingers. We'll get out the wrench in a second and tighten them up. And let's go ahead and do that right now. It should also be noted that you want to save the tightening of the coupler screw to the last part. Namely because if there's any wiggle or any tension, or if you back the screw in, at an odd angle, you want to be able to correct that. And the lead screw is usually the least forgiving part of the step. Actually, it's the most forgiving because of its flex coupler, but you still want to get into the process of tightening that last. Because there's actually 2 sets of screws that you have to tighten to get it done. And one more quarter spin, and we're good. And obviously you can already see the thing coming together. Now I'll put the other gantry face on and do the same thing to it. Take large socket cap, thread it in so it sticks. Do the same to the other side. And now tighten them up. And these should only be taking about 3/4 of a turn if you got them good with your fingers. So here's our x-axis table. As you can see, when we spin the lead screw, the actual anti-backlash nut part that's attached begins to spin. We haven't coupled these together, which is why this only moves in one direction, namely the forward travel. But as soon as we attach, let's see, this plate, or actually it might be this one, we'll get to see both of them move. Pretty sure it's... And now for the y-axis, set that off to the side. These are the 2 y-axis shoulders. These are a little bit more involved because you actually have to screw them together. It's a box, not just a... So we're going to want to follow the basic same procedure we did before as far as putting the lead screw through and kind of going from an inside out perspective. Once again, hold that screw in place while feeding from the back. Once the back is in a few turns, do the other side. Once it's in, just roughly, now come along and tighten it up. Which this gives me an idea for the next thing I should make for this system is bore holes here and here, or on various parts for limit switches, which this thing doesn't seem to support yet. Should have probably just tightened it with my fingers, it'd be much faster. And obviously, again, give it about 3/4 of a turn. You'll feel the give. I just felt it a little bit there. You'll notice that when you spin it, motion transfers a little bit, but most importantly, this thing actually traverses. So get the other part, screw side facing up, give the next largest set of lead screws, which are these, stick them through. Just roughly like that. And take one side. And here we get to prepare more bolts. Whoa. Actually, you can probably use a smaller set. Where is a smaller set? Aha. And exact same thing here. Take screw, thread on with your fingers. And for the other side. Huh. Okay, I see what I did here. What I did was I should have bolted this on the inside. I'll stop the video, I'll correct that, and I'll bring it right back from where we started. This is my first attempt at building a CNC mill. Obviously, I'm as prone to errors as anyone else. Please forgive me, I know how YouTube people can be. Alright everyone, I'm back. Just had a little bit of a technical mishap there. Basically, these bearing blocks need to go on the outside of the motors. I wasn't aware of that or responsive to it at the start, so I kind of screwed that up. And where'd those screws go? So now we're ready to finalize the Y table. Obviously, washers on, thread them on, then tighten them. Once these are tight, so I will go back to the x-axis and take care of that in a second. Once the two slide rods are tight, that's when you can go ahead and finish screwing down the stepper motor, so that the actual stepper motor and lead screw combination is up to spec. So let's tighten these real fast. As I said, you only need about 3/4 of a turn at max. Once that's good, then you can tighten the lead screw. Now is the point at which we can attach the table, the actual sliding bed, but I'm not going to until I make a spoil board, which I'll get to in the third video, which will be the last video of tonight and be the last video in the series. So now that this is complete, we have one thing left to do on this, and that is screw in all of these panels. So slide these into place and go outside, outside, inside. So put the two on the outside in first and finally do the last one. And these may take a little bit of coercion to get going. Obviously, the fit on this entire machine is tight, and that's a good thing because that means it's going to be accurate. Spin this bitch around. Do the other side before doing the insides on either side. The reason why I'm holding off on putting the final actual table on is because we need to make a spoil board, which is a board that will absorb any misdirected cutting force. So if in your G code or CAM software or whatever you specify the drill bit to make an extra excursion below the maximum depth of your piece. So say you have a piece that's 1/2 inch thick, that is 0.500. If you tell the drill bit to go 0.510 to be absolutely sure you can part the piece out, on this table it would start to bite in to the table. So, and that's the exact job of the spoil board, to absorb that flak. You can change out the board later, but it's a sacrificial kind of component. Tighten these up. And then do the middles. And I just realized that this is an important lesson on why you do not rush to a process for a YouTube video's sake. This component is supposed to be the front. These sliding variable bolt holes correspond to these 2 points. So this is supposed to be flipped around. As soon as I get this screwed in, I will end the video, fix it, and resume. But let's get this one done correctly first. I know I don't need to show you how to screw anything more in, but it's a matter of principle. Alright, I'll end this video here and correct that issue. But now you can already see how the whole CNC mill is going to come together. This entire head unit will mount right in these flange seats. Then the Y-axis and the Z-axis mounts here. So we are very close to having this done. Alright.